In this video, I want to give you an introduction to solving two-step equations. And much like our one-step equations, most of them are fairly simple, and in fact, most students can come up with the correct solution simply by visually inspecting the equation. However, it's important that students learn the underlying principles for solving equations and not just rely on a visual inspection to come up with their solution. Because very soon the equations will get much more difficult and students will not be able to find the solution without using an analytical approach. I have seen too many students who don't take the time to learn the properties and principles when the problems are easy, so when the problems get more in depth or more difficult, the student gives up and fails. So let's make sure that isn't you. In this video, I want to work through 5 different examples, each one accentuating an important property for solving equations. So in this first example, we have 8 minus 3n equals 20. And so remember that the goal of solving these equations is to isolate the variable on one side of the equation by itself. Well, that's what isolate means. And on the other side, we're going to have the number. So we'll have n equals, and then its value. And of course, that value for n that we're trying to solve for is the value that when I plug it in, it makes this equation true. All right, so looking at this left side, our variable only exists in one place right now, and it's this n right here, which means there is not an n on the right side and there's no more n's on the left. So our goal is to get this n by itself. All right, well, I have 2 terms, it looks like, an 8 and a minus 3n. So the approach I need to take is going to be kind of my order of operations backwards. So we have this multiplication here, and then we have this subtraction. So typically with an order of operations, we do multiplication and division first from left to right, and then we do our addition and subtraction from left to right. So instead, we're going to focus on doing the addition and subtraction first. Now this isn't always the case, and I'll show you an example of that here in a bit. So 8 minus 3n. Well, what are we going to add or subtract? Well, this 8 right here. So in order to make this a little simpler, remember that 8 minus 3n is the same as a negative 3n plus 8. So this 8 doesn't have a sign in front of it, so it indicates that, in fact, it's positive. So when we rewrite it, we can just change the order of the terms by using the commutative property. So negative 3n plus 8. So it's pretty easy to tell now that what I want to do is subtract 8 from both sides in order to get rid of it. So we're going to use the subtraction property of equality, and we're going to subtract 8 from both sides of this equation. And our subtraction property of equality just tells us that if we're going to subtract a value from one side of the equation, we need to do it from the other side as well in order to keep everything nice and equal. All right, so when we do that, on the left side, these 8's cancel out. So I have the negative 3n equals, and 20 minus 8, well, that's 12. So I'll tell you one common mistake I see that students make. This negative 3n sometimes somehow becomes a positive 3n because they don't bring this negative down along with a 3n. For some reason, sometimes I see this negative kind of gets lost. So let's make sure that doesn't happen. So now we have negative 3n equals 12. So our two-step equation has now become a one-step equation. So this negative 3n is multiplication because this coefficient of negative 3 is being multiplied by the n. So in order to get this n by itself, we need to do the inverse operation of multiplying. So let's go ahead and divide both sides by negative 3. And when we do that, the n will be by itself. And 12 divided by negative 3 will be negative 4. So we can see for this first equation, the value of the variable is negative 4. And that's the value that will make this equation true. And in fact, it's the only value for the variable that will make the equation true. And so let's go ahead and plug it back in just to ensure that it works. So we have 8 minus 3n. And of course, our value for n is negative 4. And we're going to say that equals 20. All right, so here's the order of operations that we talked about earlier. So now the first thing we need to do is the multiplication. So negative 3 times negative 4 is going to be 12. and 8 plus 12 is 20. So we can see that 20 equals 20, and negative 4 is the solution for this first equation. In this second example, we have negative 5 minus k equals a positive 13. So once again, in an effort to get this variable all by itself, right now it's a negative k, so I need to get rid of this negative 5 first. So we can see that it's a negative 5, so it's being subtracted. So we're going to do the opposite, or the inverse operation of subtraction, and we're going to add 5 to both sides. All right, so that's nice. Those 5s cancel, and we have a negative k. And as I mentioned in that previous example, this negative, don't lose it. Okay, it needs to come on down here for the ride because he's there. So 13 plus 5 then is 18. Well, an important principle here is we're trying to solve for k, not negative k. So be really careful that you don't say that k equals 18 because it's not k, it's negative k. So really this negative k is actually a negative 1 times the k, and that's the way our coefficients work. This negative in front is really a negative 1 times the k. So in order to get the k all by itself, we need to, in fact, divide by negative 1. And the division by negative 1 will cancel these negatives. It will get the k all by itself, but it will also change the sign on the right side. So 18 divided by negative 1 will end up being a negative 18. So in this case, our solution is negative 18. So let's go ahead and plug it back in just to make sure it works. So we have negative 5 minus k, and of course our k is negative 18. So when we subtract a negative, we can do a little swoosh swoosh there, and it's negative 5 plus 18, which is 13. And of course 13 equals 13, so that's true, and this value for k is indeed negative 18 for this second equation. In this third equation, we have negative 4 times the quantity, and we have y minus 5, and that equals 20. So a lot of times students will see the parentheses and they think automatically, well, let's go ahead and distribute. But by distributing here, it actually makes it a 3-step problem instead of just a 2-step problem. So how can we limit the amount of work we do and still get the correct answer? Well, this negative 4 is being multiplied by this y minus 5 expression. So to get rid of this negative 4, how about we actually start by dividing both sides by negative 4? So when we do that, the negative 4's will cancel. I'm left with just the y minus 5 on the left, and on the right side, 20 divided by negative 4, well, that's negative 5. So y minus 5 equals a negative 5. So to get that y all by itself, I'll do just one more step, and I'll get rid of this negative 5. And so we'll use the inverse operation of subtracting 5, and we will add 5 to both sides of the equation. All right, that's nice because on the left side, those 5's cancel, so the y is all by itself. Interestingly enough, on the right side, those 5's also cancel. So what is the value for y? Well, negative 5 plus 5 is, well, 0. So in this case, y equals 0. So the only value that will make this equation true is if y is 0. Well, let's go ahead and plug that in and see if that's true. So negative 4 times, and we have 0 minus 5 equals 20. Well, 0 minus 5 is negative 5, and negative 4 times negative 5 is positive 20, so 20 equals 20. So the correct solution then for this third equation is indeed y equals 0. In this fourth example, we have this m minus 3, and that entire expression is being divided by 7, and then that equals negative 2. So once again, our goal is to isolate this variable m. So get it by itself on one side. Well, this whole expression, m minus 3, is being divided by 7. So before we can add 3 to both sides, or before we can really work this numerator, we kind of have to get rid of this fraction. So since the m minus 3 is being divided by 7, let's go ahead and do the opposite of division, and let's multiply both sides by 7. Well, on the left side, that's really nice because these 7's cancel, and I am left with just m minus 3. And on the right side then, negative 2 times 7, that'll be a negative 14. So now my two-step equation has turned into a one-step equation. So to finish getting m all by itself, I have m minus 3. So let's go ahead and do the inverse operation of subtracting 3, and let's add 3 to both sides. And this, again, is the addition property of equality, and that just says when you add a value to one side of the equation, you need to do it to the other side as well to keep everything nice and equal, nice and balanced. All right, on the left side, those 3's cancel, leaving me with just that m, so m equals, and let's go ahead and do this integer addition, so negative 14 plus 3, that'll be negative 11. So the value for m in this case is negative 11, and once again, let's go ahead and plug it back in just to ensure that it works. So I'll go ahead and write the whole thing down. Let's plug negative 11 in for m. And so negative 11 minus 3 is negative 14, and that is being divided by 7. So negative 14 divided by 7 is negative 2. So negative 2 equals negative 2, and that works. So that means then we were correct, and this value for m that will make this equation true is negative 11. In this fifth and final example, it looks like we have an equation that contains fractions. So how could we have a good math video without an example with fractions? All right, so this x here is our variable, and it looks like it's over here on the right side. So sometimes students at this point will try to multiply through in order to eliminate all the fractions. And I think that when the equations are more difficult and there's lots of terms, that's a good way to go about doing this. But since these are fairly simple fractions and it's only a two-step equation, I'm just going to work with the fractions. So the first thing I'm going to do, I need to get rid of this negative 2/3. So let's add 2/3 to both sides of the equation. And so when I do that, it looks like I have 2/5 plus 2/3, and that will equal 4/5 times x. Well, we have the fraction addition here, so it looks like we're going to need to get common denominators. So between 5 and 3, it looks like 15. So we'll scale each of these fractions to have that common denominator of 15. So multiply the first one by 3 over 3, and we'll multiply the second one by 5 over 5. So when we do that, we'll end up with 6 over 15 plus 10 over 15, and of course that still equals that 4/5 x. Well, now that we have our common denominators, 6 plus 10 will be 16 over 15, and that will still equal that 4/5 x. Okay, so now we're at a point where we are ready to get this x by itself. And so right now it's being multiplied by the 4/5. So it looks like what we need to do is divide both sides of this equation by 4/5. But remember, when you're dividing fractions, aren't you really just multiplying by the reciprocal? So instead of calling this division, let's go ahead and call this the multiplication property of equality, and let's actually multiply both sides by the reciprocal of this coefficient. So you'll see the 4's cancel, and go to 1s, and you see the 5's cancel and go to 1s. And of course this x now will be all by itself on that side. On this left side now, it looks like we can do this fraction multiplication by simplifying a little bit first. So let's go ahead and factor and cancel a 5 out of the 5 and 15, which will leave me with a 1 and a 3 respectively. And it looks like a 4 I can divide out of the 4 and the 16, so that will leave me with a 1 and a 4 respectively. Well, I have my multiplication here. 1 times 4 is 4, and 1 times 3 is 3. So it looks like 4/3 is the value for x. And one more consideration you could make. Some students like to see this variable on the left side instead of the right side. So you can just go ahead and switch these two sides of the equation. This is a property that's called the symmetric property of equality, and it just states that if we have two expressions that are equal to each other, and we know they are equal to each other because 4/3 equals x. We're stating outright that they're equal to each other. Well, when they're equal, you can go ahead and switch the two, the left one for the right and the right one for the left, and everything stays nice and equal. So we can see in this fifth and final example, our value for x will be 4/3.